University. Actually, I'd like to welcome the European UNC to the APMC. I'm from APMC side, so my talk is not important. I try to keep the schedule right. So the talk is about advanced duplex system and separately there's cancellation demonstration that our lab have been working. So I start with advanced duplex. Actually, that is in-band duplex and sub-band duplex together. So I talk about the concept of advanced duplex and how we're going to achieve suppression and cancellation, and then show our research work. So I think we all familiar with in-band duplex communication. So compared to FDD and TDD, we share the frequency and time together. So we have the we have the full time and frequency together. So we can achieve times more data rate compared to FDD or TDD. The problem is circuit interference because we are transmitting signal while we are receiving. So our transmitted signal is going to be circuit interference for our receiver. So the more important thing is we can do some kind of cancellation, but there is cross-link interference because another UE have affect the interference to this UE. So we cannot have cancellation for this. This is one of the reasons we cannot have deployment for this embedded for the practice system. So they propose new system which is sub-band duplex for 6G standardization. So in this case, UE does not do the duplex, and only G0B have the duplex. So UE keep the time division duplex, and only G0B have duplex in this case. So why we doing UE transmitting at this time slot? It will have cross-link interference to another device, but the frequency is different, so we have a little better situation, reduce cross-link interference. But at the G0B side, they support UE1 and UE2 together. They have to do the duplexing. They transmitting this frequency and also receiving this frequency. So they are overlapping each other, very close to each other. So we need to have some kind of relation. So this is sub-band duplex. They propose this for the ultra-reliable rate transcommunication. For this case, if UE are urgent, they can transmit onload the signal to the G0B, so they are good for urgent request and ultra-reliable rate transcommunication. And then now people saying advanced duplex. In this case, it combines all together FDD and TDD, and this sub-band duplex and even in-band duplex. For sub-band duplex side, they call in-band duplex shared spectrum duplex. So at some time, we will achieve this advanced duplex for communication. So what we have to do for this is, let's say we're transmitting the signal at 20 dBm, and our noise floor is like -9 dBm. To achieve full duplex, we have to cancel or reduce the transmitting signal to this noise floor. This is going to be 110 dB isolation or cancellation. But we can rely on a little bit on digital cancellation depending on ADC dynamic range. Let's say if we can rely on 50 dB digital cancellation, we need to achieve 50 to 6 dB analog cancellation to reduce the transmitted signal to the lower level. So generally for RF front end, we have to achieve 50 to 6 dB separate interference cancellation. So how are we going to do? The first thing is we have some kind of antenna passive suppression. Let's say if we use two different antenna, we will have some kind of isolation, but this is not enough. So if we have to have another mechanism. So we call this is canceller. We tap a little bit of power from PA and cancel at the RF front end. So we reduce the signal more. And if we can rely on analog SIC cancellation or even the cancellation. But for my side, we rely on the antenna and RF circuit as cancellation. There are a few ways to have the antenna passive antenna. So polarization difference will give us some isolation. Maybe the famous way is using circulator, but circulator is also limited by the isolation. If you try to increase the isolation, we have to do some kind of good matching or reflection coefficient control to have higher isolation between TX and X. If we want to increase the antenna, so like 2x2 MIMO, then we can combine these together. So two different antenna and decoupling network and circulator. Or you can use the dual pole antenna, or you can use dual pole and decoupling network. This is all possible way to achieve. So once we have two antenna separation by some way, we need to put some canceller between TX and X. If we increase by 2x2, then our canceller need to be more like between old antenna. We have many canceller. In some cases, if we are going to make phase early using this technique, but there are too many antennas, we can use this canceller. We should have two separate already, and we can add a canceller between them. So how we can make self-interference canceller? In our lab, we use attenuator, phase shifter, and time delay circuit. By attenuator, we can control the TX signal magnitude, and phase shifter can control phase. And if we want to make the cancellation wide at the wide bandwidth, we need to change the phase slope or group delay. For our side, we don't want to use two time delay circuit, which is too large to make. So we develop group delay controller, and by doing this, we can control group delay. Actually, phases stay, but only the group delay change. Other than that, phase shifter and attenuator should be designed all together for the circuit. And another thing is, usually one tap, the single attenuator, phase shifter, and time delay circuit has very narrow bandwidth. To make it wider, you may have to put many of this canceller. So we call this is multi-tap. In this case, we can canceller. If we have time delay limited, we may have some fixed delay added in this circuit. So this is our research work for FR1 frequency for 2x2 MIMO system. So we use two antenna, and between these two, we put the decoupling network. And we use circulator to increase this isolation sample. We use reflection coefficient controller. So by controlling this impedance, we have higher isolation between TX and X. And between these two, we rely on the decoupling network. So this is 2x2 system for each TX to each RX. We should have canceller. In this case, we use 3 canceller, and all these canceller need to be controlled. So by doing this, we're trying to achieve 30 dB isolation at the passive suppression side, and 30 dB isolation and cancellation side. So this is the circuit that we made. So two antenna and decoupling network and circulator, and all the canceller, 4 cancellers are designed here. These things are the fixed delay filter to have long enough delay. So by controlling all the circuit for the 200 MHz bandwidth, we can achieve the isolation around -55 dB. If we control in a narrow bandwidth, for this case, dB isolation that we have planned. The last thing is FR2F4 for the phase delay duplex system. In this case, we use two 8x8 phase delay system, or for this, the isolation rely on the polarization difference. So this array use H port, this array use V port, and we have a canceller between two array. And this is the canceller for 2 tap. Actually, this is designed at the 29 GHz, so we have used the beamformer IC. Then we have used the beamformer IC for this array. We also use it for our canceller. developed two RX and TX array using different polarization and canceller, and also we can achieve 6 dB isolation. So this is the isolation between array. By cancelling these two, we have increased the isolation to 6 dB. So that's it. So I talked about advanced duplex system using passive suppression and self-interference cancellation. So we try to demonstrate FR1 advanced duplex and FR2 advanced duplex system. Thank you very much.
Thank you for your talk, and then we have 1 or 2 questions. Yes. Any queries or suggestions from the platform? If not, I think the initial work, I think what you had shown around 3 gig band, your group delay was, or group delay of the linear phase is very narrow band, within 200 meg, right? Why it is so, or your specification is like that?
Actually, this is at the 3.7 meter. So if we try to use 2 time delay, it's very different to have this frequency. So it's better to have 2 delay. And as it is narrow band, it's good enough for our system. So right on the next time, it's good enough for
Any suggestions to enhance their linearity or the group delay? For suppose if some application needs the slightly wider band of response.
Actually, there is trade-off between group delay bandwidth and dynamic bandwidth. So if we reduce this dynamic rate, then we can wider this bandwidth.
Okay. Okay. If there are no other questions, I think thanks for the speaker.